Hey there, my gorgeous friends on the internet. Today's episode's about hooks. Not the captains, but reacts. That's a terrible joke. Oh my gosh. So I'm gonna try to cover all of them to the best of my abilities. There's so many of them, and there's so many weird ones as well, like useMemo, transition, and callback, and just use now. There's one just use. Like, at what point do we stop and just switch over to Svel? That's my question. Anyway, let's start getting a look into this. What am I saying? And yeah, drop a sub, drop a like if you like this content. I really appreciate it. And check out my courses down there below as well. Okay, let's start off with the first one, and this is the most popular one, called useState. So this is a hook that gives you the ability to re-render a component in React. So we have a count here, so you basically make an array like that, and it takes in the count, which is the actual variable that gets updated, and then a setter, which is a function here. So here in the useState, we set the value. In this case, it's 0. Of course, we can render that out on the screen if we add count here, like that. As you can see, it's 0. And then I just set an on-click on it, where we can take the set count, and in the set count, we'll just update count with 1. And if we click, as you can see, we get 1, 2, 3, 4, 5. It works perfectly fine. Let me drop that in a H1 so it's a bit easier to see, just like that. Cool, so that works. A thing to keep in mind is when you have another component that's being rendered in your app here, and you're using useState and updating a value, that contact is also gonna get re-rendered even though nothing is changing in this component. So if I hit here, and it's not doing it now, of course, let me refresh. This extension tool is really funny. Highlight. It's clicked. Oh gosh, come on. There we go. So as you can see, contact has a rectangle on top of it, meaning that it also gets re-rendered. Another thing to keep in mind is that set count here is asynchronous, and if I call it multiple times, it's just gonna get batched together. So let me show you. I'll create a function called increment. And all this increment is gonna be is an arrow function where we are gonna update. We should name it const increment. There we go, is equal to, there we go. And here we'll just say set count, and we'll do count plus 1. All right, perfect. And then we'll copy this multiple times down here. So rather than doing set count here, what I'm gonna do is just call increment. There we go, and hit save. So what kind of behavior do you expect it to be? Well, we're only gonna get 1 here, 2, 3, 4, even though we call this multiple times. The value here is not the latest one that we're gonna get. And this is all gonna be batched, and basically this is gonna be 0, 0, and 0 every time set count takes a look at it. So if you do want to chain together multiple updates or setters, or maybe you really want the latest value, you need to not use count here, but to actually get the previous value from the set count. So rather than doing this, what you can do is actually have a callback here saying set a previous counter. And then here you can get the previous counter and update the value like that. So now if I copy this 3 more times, you're gonna get the value that you expect to get. So here it would be 0, but by the time it gets to this line, it'll be 1. So it'll be 1 plus 1, and here it'll be 2 plus 1, giving you 3. So if I click, 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 as you can see, it keeps getting incremented by 3. So as best practice, I always advise to use just the latest value from here. Otherwise, you might encounter a couple of weird, funny bugs that is quite hard to decipher. So that's useState. One of the most important concepts in React is useEffect. And what useEffect is essentially side effects. Because every time you call useState, your component gets re-rendered. But sometimes you might want to run code that's outside, totally independent from that rendering system. Because in this case, look what I have here. I just have a useState with an input, and every time I type here, we're outputting that input's value right here. But this component gets re-rendered every time. So what if I also want to do like a fetch request? Like I want to fetch some data maybe on this input. So maybe I'm searching for like a joke here. If I just call fetch here, that would be not okay. I can even do like a console log and just say re-render, because what happens, we learned that whenever you call useState, this component gets re-rendered. So you could imagine if I start typing and I'm making API requests over and over every time here like that, that's not too good for us. So we have to somehow try to make the API requests either only once or have the ability to control when it gets re-rendered. Because I could have another variable, another state in here called like counter, the one we had before, and set counter. And if I set that equal to useState, and I'll just pass in like 0, look, if I start updating this, for example, so on the useEffect, I'll just add an on click and say set, run an arrow function, set counter, and I'll just do prev counter +1. There we go, cool. So now take a look at this. When I click there on my counter, this still gets re-rendered. So no matter what part of the state changes, this code is gonna keep running and running every time. So what we can do rather than doing this is add a useEffect. So if I go down here and say useEffect, this is gonna take in 2 parameters. One's gonna be an arrow function, and the second argument is gonna be an empty array. And what the empty array means is that this code in the arrow function is only gonna run once when the component initially gets rendered for the first time. So if I say rendered for the first time and hit save, you're gonna see if I go to inspect, go to console, we are only getting it once. Even though I'm typing here or clicking here, that is only running once. So perfect. So this would be a perfect place now to do a fetch request. It would be a great place to do something like document.title. I can update this and say it works. So again, it's gonna wait for everything to be rendered out on the screen first, and then it's gonna run the side effect for us. So now it's very safe for me to go in here and just say input like that. Again, it's only gonna run after, so when I type, oops, as you can see, actually it doesn't work, it doesn't get updated. Why? This is what this dependency array is for. If you pass in a prop, if you pass in a state, this useEffect is also gonna run every time that prop or state is being changed. So not only for the first time, but also every time it updates. So if I add input in here now and hit save, now, as soon as I type, as you can see, after the component gets re-rendered, that also gets updated up there. Boop, 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 boop. Perfect. So this gives us really good control, because if I click on useEffect here, remember that's our increment button, as you can see, that component gets updated, but this code here is not gonna run anymore. Console log useEffect. Let's add that. So it runs for the first time, it runs when we update our input value, but not when our counter value increases. All right, so it gives you really good control on what you can do. Check this little example out. I have a const incrementer here that just sets a interval and updates set counter to counter +1, right? Now, if I refresh, you're gonna see that we're getting 2, 4, 6, 8. So why is that happening? The thing is that with useEffect is we're mounting the set interval, but we're never getting rid of it. We're never clearing. So if we navigate over to other parts of our page and coming back and this component gets remounted, it's gonna add another set interval to our call stack, giving you 46, 48. So what you need to make sure with these useEffects, sometimes you might actually need to clear out the interval. So we can say return here, and we can just say clear interval, and we can pass in the incrementer like that. And that should clear up everything. And look at that, we are getting 1, 2, 3, 4, 5. Also, be really careful with useEffect, because if you are updating a a piece of state here, and if you have a dependency here on the same thing, so if I have counter here, it's really easy to create an infinite loop, because what's happening? Well, this useEffect is gonna run when counter gets changed, updated, right? But what does that mean? It means that we're running this whole code again, because we're setting counter again, which is gonna cause a re-render, which means we are gonna set another interval. All right, so it's very easy. Just be careful with the dependencies, because if you have a dependency and you're also changing the state in the useEffect, it can cause an infinite loop. So be aware. Okay, next one is useLayoutEffect, and this is very similar to useEffect. And there are quite a couple of places where you might need this over useEffect. So useEffect actually waits for the component to be rendered on the page and painted, and you see all the content and the styling, and then it runs. Whereas useLayoutEffect runs before the content gets painted on the screen. And why is this useful? Because there's certain situations where you might get flickering on your screen, either from styling that you might want to apply with useEffect, or certain updates that you might want to do. So in this case, check this out. I have that same counter that's set to 0, and in this useEffect, I'm basically running a test and saying, hey, if the counter is 0, generate me a random number. And down here, what I'm doing is I'm just setting the counter to 0 every time. So when I click, it does work, you're gonna see, but the actual screen here is gonna turn blank for like a millisecond. Now this is quite quick, but it flickers for a little bit right there. Now again, why is this happening? Is because this useEffect runs after the actual value gets printed out. So you're actually gonna get that 0 here for like a split second. Okay, you can also think of it like when you're doing an input check, right? Or maybe a user, you might get that flickering for like half a second. So what useLayoutEffect is gonna do is gonna run synchronously, and it is gonna block your code for a split second, but it's gonna avoid that flickering for you. And when it paints, it's gonna paint with the updated value already, and it's not going to flicker to that 0. So check this out. All we need to do is change this to useLayoutEffect, and that's it. It's the same callback function that it takes, and the same dependency array that it takes. But now, as you can see, no more flickering. All right, next up we have something called context. Context essentially allows us to share application state between all of our different components. So what we do here, I put together an example here. I'll just go through it really quickly. So we have a counter context here. So this is just the types to add to our counter here. So we have a count, that's a number, an increment, and a decrement that don't return anything to us, so just void. And we're just setting up the interface here just so we have nice TypeScript support. But what we're doing essentially is creating this counter provider. And this is going to have some sort of state. So in this case, it's just the counter. And then we have our functions to increment and decrement that. And then the values that we want to export as well. So in this case, the count, we want to export the increment and decrement. So here, when we're returning, what we're doing is we're passing in this value object that we just made here. And this value object is going to be available to every children that is wrapped in this provider. All right, so just wrap your app in this context provider, pass the values that you want for the rest of the components to have available, in this case, these three, and that's it. So you create the context provider. And down here, I just have two different components. I made it's in the same file just to keep it nice and simple. All right, but this is what we're rendering out in our app. So we have our counter provider, and we have our increment counter and decrement counter. All right, so two separate components. And if we want to use the context, all we need to do is import this use context and pass down the provider that we want the data from. So in this case, our context provider, right? And then all we're doing is we're returning a button that has an increment on it. Again, we can get any values we want here. If I want the count, I can render that out here as well in this component if I want to. So I can go here and say h1 and count, and that's gonna work fine. We just need to make sure we wrap it like that. And I guess we don't have a div, so we can just make a fragment and pop it and pippity poppity pop, boom. There we go. So you can consume all of that as well. Now, I personally don't use context because I use external packages that I feel like are just a tad bit better than React solution that they give here. So what I tend to opt for usually is TanStack, because they have caching as well already included in the box. It's very easy to share state across all the components and have that ability to control your caching to like down to a T is really important. Because one thing about context is that once your context value updates, all the components that are consuming that context will get re-rendered. All right, cool. Let's have a look at useReducer. useReducer is like state, but you can customize it more and you can add a bit more complex logic than this. Because here you're just passing a value and you have a setter, and that's pretty much it. But let's do that. We'll go here to the top and say const initial state. And what I'll do for now is I'll just make an object and I'll pass in one value, which is going to be the background color, like that. All right, and the default is going to be, let's say, FFF, which is white. Perfect. So we have our state, and then we'll create something called a reducer, which is going to take in a state and an action. All right, what the hell does all of this mean? Well, we're going to make a switch statement here and take in the action. And the action, again, just describes what we want to do. And this can be anything. So I can say case black, right? So if it's the case black, then what I can do is return my background color as 0. What is it? Is it that? I think that's it. Perfect. And then we can have another case for red, for example. And here we can return a background color of red. And then we can also add a case of default. And here we can say throw new error, or we can just always have it as return background color, and we can say initial, like that. Cool. All right, so now that I'm missing the arrow function here. This should be a function like that. So that's perfect. And now we can import this useReducer like that. And rather than using this, we'll say const state, comma, dispatch. And we'll set this equal to useReducer. And we'll pass in the reducer that we just created and also the initial state and hit save. Perfect. All right, so now that we have all of that hooked up, we can start using it. So I'll just get rid of this increment counter here. We won't need this. We won't need this either as well. And just clear everything up like that. Cool. So I'll just add a h1 here and say hello reducer. There we go. And I'll go on this one, add the class name, and all we'll do is add some backticks and say background. Oops. Actually, we need a style. Haven't used this in ages. So we'll see background color is gonna be, take a guess. What is it? Well, we can get our state background color. There we go. As you can see, it's all white. So now what we can do is use this dispatch to dispatch all of these actions that we have. And all you need to do is essentially pass down the keyword of the action that you want to dispatch. So if you do black, then it's going to return you this. So let's go down here and I'll just do a button here and we'll say turn to red. So I can just go here and say on click. What I want to do is dispatch, and I can dispatch red and hit save. So poof, done. And you can do the same thing. You can dispatch something else like black and take a look at that. All right, so it's a different way of creating state. I do like it. I do appreciate it. But these days, to be honest, if again, you're using something like TanStack or something like useState, for example, that's something that I would opt for, to be honest. So useState is super nice.
Bulletin received.
Because you can create these nice compact states that can be shared across all of your applications. Has TypeScript support and everything, and it's just so much easier to get going. Okay, next up, let's talk about refs. So in React, you're probably gonna find that, like, how would I get the height of this element, for example? Because there's no real easy way of just going here and doing the document.query selector, right? We're not working with vanilla JavaScript, so we're not going to write any imperative code. So rather than doing document query selector and stuff like that, and you want to reference to this, let's say we want to focus this, or, you know, again, maybe use some sort of intersection observer, so when we scroll in, this will be visible. So we need a reference to this. So what we can do is use this useRef. So what you do is literally just create any variable. Let's call this title ref. Set that equal to useRef. And then we can pass this down right here as a ref. Poof, like that. So now we actually have a reference to this. This is just a TypeScript error, so don't worry about it. So now I can even use like something like a useEffect. So after our component gets rendered out on the screen, I can maybe get its height to see what's going on. So I can just say something like title console log title ref.current. That's how you select it. And then here again, whatever you want to do. So there we go. We just add the ref, and then here we have the ability to control it to our heart's content. Let's talk about useMemo. useMemo allows us to essentially cache a value. We're essentially stopping it from re-rendering every time a component re-renders. It essentially saves the value, and it's going to reference it after the next re-render. So what I have here is a count that's set to 0, and we have some sort of expensive calculation. Yeah, this can be anything really. And then down here, what we're doing is we have this rendered value, and what I'm doing is calling this useMemo on it, like that. See, so it kind of looks like useEffect in terms of it takes in a callback function and then an empty array. And this array, again, if I add count here, then it's gonna invalidate that cache and re-render every time count changes. But if count is not changed, then it's gonna maintain and keep the state. So take a look at this. We have rendered value, right? It's just gonna generate a random number here. And if I click refresh, as you can see, it generates it for us. Perfect, that's what we want. However, if I click count here, that's essentially gonna re-render my component. But since we're using useMemo, as you can see, that stays cached and we don't need to worry about it anymore. So that's fantastic. Now again, if I do want it to update based on that, then I can just pass down count here. And now every time we click that, we can run that expensive computation. So you can imagine you might have components that don't really need to be updated every time maybe a counter or a piece of state changes in your code. You can solve that by adding a useMemo on it. Okay, next up, let's talk about useCallback and useMemo. And gosh, I hate this. I hate this so much. Why does React have all this shite where we have to go deep dive into all the internal workings to figure out why everything re-renders? Oh, this is why I just love Svelte, and I'm tired of all this React shite. But anyway, so what's the idea with useMemo and useCallback? So useMemo essentially lets you memoize or cache a value, and useCallback lets you do that the same for a function, because the important bit here is if we have two identical functions, you can imagine, they're not going to be the same. So basically on every re-render, even though your function, looks the same, in this case here we're just setting a count, on a re-render, this won't be the same one that's allocated in memory. So it's gonna have to be rebuilt. Meaning that, take a look at this. So we just have a count here and we have a handle multiplier where we take that count and just multiply it by a value. And here, this first button, we're just increasing the button, and this lets us multiply it like that. And what we're doing is we're passing down this function down here into our multiplier. Now remember, if the component gets re-rendered, this prop technically is going to change because the function is going to be different. Meaning that if this is like an expensive computation that you're doing here, this is like a simple example, but you can imagine maybe you're filtering out a large list of users or a large list of movies or something, and then this might become a bit more inefficient. But generally speaking, again, React's gonna do fine for simple stuff like this. Unless you have something that you could really tell is slowing down your application, you won't even need to use these. Okay, so what can we do? Well, we can go here, and if we check, I just have a console log render multiplier in here. And if we check the console, if we click on click me, see, that still renders out this component for us, which is not what we want to do. So what we want to do is essentially is cache this function here, so it won't be reused on every re-render. We basically have a snapshot of it and we can just reuse it. So what we can do, and by the way, useCallback and useMemo, you can pretty much like use both here, to be honest. Try this again, react.useMemo. All right, so here, so we need a callback function, and we're returning a function like that. That should be fine. Set my count. We got the previous count and the previous count times blah blah blah. What is wrong? Oh, my dependency array, no. There we go. Okay, so there we go. So let's pass this down now, handle multiplier, and pass it down here. Cool. And the last thing I'm gonna do is wrap this into a memo like that, which essentially is gonna make it a pure component. Okay, so, and there we go. As you can see now, render multiplier gets rendered once. We can click, 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 and if we click multiplier, look at that. We are changing the value of that, and we are not re-rendering that function anymore, or that component. So that's it. And again, if you want to turn this into useCallback, you can do that too. Again, it's more like syntactical sugar. So all we need to do is change this from React useMemo to useCallback. And again, this is gonna cache basically our function for us and save it between re-renders. So we don't even need to return a function here. We could just get rid of all of this and do a set count like that. Perfect. And there we go. And again, the way this works again is basically the array here is the dependencies that would invalidate that cache for you. So if I press count down here, that would invalidate it, meaning it would, as you can see, it would just re-render again and recreate that function for you. All right, but that's it. Again, it's technical mumbo jumbo that we shouldn't really care that much about, but it's here. Okay, finally, let's look at use transition. What use transition allows us to do is to offload code that is not urgent to be rendered out. So in this case here, I have this input here and I'm fetching some Pokemon. So I'm just using a useEffect here and I'm fetching it and I'm setting the set Pokemon over to data results. All right, so down here, I'm just looping over it and I'm outputting it on the screen. Now the thing is though, I also added this filter Pokemon here, and all it's doing is it's checking to see basically on the input if it includes any characters. So basically if I type B, as you can see, we have all the Pokemon with B, Bulbasaur, All right, so this is all getting re-rendered right here. So this is fine, but if you have a shite computer, and imagine we're making an API request to a list that's really large, and if we let our CPU just basically update like that on every keystroke, it might cause our application to really bog down. So what you can do is use something called the use transition hook to essentially improve the performance of this filtering operation. So when the user types, the use transition hook will essentially mark the state update as a non-urgent update. This means that the filtering option will be essentially executed in the background while the component keeps continuing to be re-rendered. So let's look at how this is implemented. So what we can do is here in our handle change, where we're setting our input, I'm gonna go to the bottom and I'm gonna say start transition. All right, and this is gonna take in an arrow function. So what we can do is add the start transition and set our filtered Pokemon in here like that. And now what we can use from this use transition hook is the isPending and start transition, right? So we use that one here, and our isPending can be used down here in our UI. And that's it. Now the filtering operation will be executed in the background while our component keeps getting re-rendered. And once the filtering option is complete, the callback function will be executed and the filtered Pokemon list will be updated. And there you go. So did you get any of that? Hopefully you learned a thing or two. I know this is quite difficult to grasp and understand. And to be fair, like if you go down a route of using something like Next.js, loads of the caching and optimizations are done by Next, so you don't need to worry about it as much. And again, loads of other libraries solve the issues that React tried to solve. So when it comes to state management and caching, Tanstack Router is fantastic for that. For any client-side state management, maybe you want, to update a product, or a shopping cart or something simple like that. You have Stand with fantastic support. So don't close yourself up to just like what React offers, because that's kind of what makes the React ecosystem nice in the first place, is the external packages. But the funny bit is, in Svelte, everything just kind of works, so you don't even need the packages. But I'll let you think about that. Until next time, I don't know. I'm really feeling the need to get into game development, and I want to do some Arduino tutorials as well. Let's learn about physical hardware, because it's fun. It is. It's really fun. Trust me. If you've never tried it before, get yourself an Arduino kit and get your cables ready, because we're going to do something cool. All right.